The systematic collection and management and maintenance of requirements is an important concern in many technical and embedded software systems. So mbeddr provides direct support for that. So let's go into a requirements module here. And as you can see, requirements are, essentially have an ID, they have a kind, there are different kinds, you can extend that, they have a priority, and they have a short summary. In addition, requirements can also have an arbitrarily long additional description text, and we are working on something better here where we actually can mix content, but that's not really quite discussed yet. So, and then requirements are essentially trees. So for example, this faster 100 and faster than 200, they're child requirements of this guy. And if you open these requirements, you can enter additional things like, for example, this requirement requires another requirement to be there, or some requirement conflicts with some other requirement. You can also, in this view here, you can filter what you see. There are filters, for example, that says, please only show me the, let's say, I don't know, scenarios. We don't have any here. Sorry for that. Please show me only the functional requirements, or show me only those whose name has the word point in it, and so on. So you can kind of work with this stuff a little bit. Requirements can also import other requirements modules with this imports statement. So this is the basics of collecting requirements. Now, you can also trace from implementation artifacts to requirements. So let's go into the state machine here. You've seen the state machine before, but now it has these green labels in it. And these green labels are requirements traces. They point from any implementation artifact, any program element expressed in any language, to one or more requirements. So you can mark something, let's say, I don't know, this state, and attach trace, and then you can select one or more target requirements. And of course, this means that this state implements these two requirements. And you can then also go to these requirements and say, do a find usages and tell me the traces, and then you get a list of those elements that trace to this particular requirement. And of course, you can't just implement, you can change this to other things. Test and implement are default, but you can provide your own trace kinds, of course. As usual, extensibility is the biggest thing here. This color coding is also interesting, and you can update these colors. See, now this one became red. Red means it's not traced at all. Blue means it has an implements trace. Green, we don't have that here, means it has a tests trace. Now, these traces are interesting because not just can you attach them to any element, but they also are really part of the element. If you move the element around or cut or copy and paste it, the trace goes along. And if you are annoyed by the trace, you can switch it off, and then the traces are still there, but you don't see them. And so you can really decide at which point in the process you want to deal with requirements traces. So this is the general high-level requirements framework. We have done a few extensions. This whole requirements language is extensible. For example, you can add any additional kinds of things here, and you can build your own languages that you can plug in here. And here is an example that we've built. This is a calculation rule. So imagine you have a business person who wants to collect requirements, but some of the things he wants to specify shouldn't just be prose text, but instead they should be formal business rules, calculation rules, some aspects of the core business logic. And you can do that, right? You can create such a calculation here. It has input parameters, and it has an expression, in this case a decision table, that calculates the result of the decision table. What's really cool about it is that there is an interpreter running here which already directly evaluates the expression for the arguments you pass in here. and this way the business person can directly in the requirements play with their own rules and see whether they make sense. Now, of course, once you have these rules expressed in the requirements, you somehow have to, connect them to the implementation. And one way, as you should understand by now, is that you can implement this thing again in C code and then set a trace, put a trace from your implementation function to this requirement and express that, you express that this implementation function implements this requirement. But you can do better. Let's go here and do a find usages. And what we should get is, here is some C code, a function indeed, which just calls this business rule, right? It's just it's a new C expression that's embedded into regular C code that directly refers to this guy. We have to strip the units because we didn't put any physical units right here. But the point is, when you then generate this C code, it essentially takes this expression here and embeds it right here. So you can directly reuse these things. Now, this is just intended as an example, right? The point is that you can build your own domain-specific languages and abstractions that you can plug into requirements by simply inheriting from a base class, base concept, and you can plug things in here. Another facility that we've built recently is the ability to work with use cases, scenarios, and high-level functional components. Let's go into this use cases thing. You can see we have different kinds of requirements. Now we have use cases in blue, we have scenarios in red. So let's take a look at a use case. Here is a use case that is called flight is interpolated. You can add additional text. It has an initiating participant, other participants. You can add preconditions and other characteristics. And of course, the things you can add to use cases is, you guessed it, extensible. So if you want to have a trigger or whatever else, then you can easily extend that. Of course, use cases can be visualized. We have a use case diagram generated. These are all the use cases in the current file. As usual, you can jump to the respective elements. And of course, these elements also include the actors, which are defined as, we call them, components and actual actors. Components are actors that are part of the system, and actors are outside. Components can have data types. They have capabilities. These are essentially kind of functions. And what you can do then is you can, for example, show a diagram that shows you all the components in your system and how they depend. Like, for example, the driver, it has a collaboration with, let's get rid of this, with the flight data provider, that's this arrow, and then you can add a comment here that says, I don't know, stores data. It's just a comment. So this whole language is intended as a very high-level conceptual description of what's going on in your system. And a bit like CRC cards. And once you have participants and actors, of course, you can go one step further and describe scenarios. So a scenario is an example execution of the system, and we visualize them with sequence diagrams. Like, you have the UI initiating, calling get a flight, it gets F back, then it calls process on the interpolator, passing an F, gets an OK result, and then iterates or loops over all the track points in F and passes them in to the judger. Once again, this serves two purposes. It shows how extensible the requirements language is, but it also, this particular extension is intended to, once you have the requirements, you're very high level, you have high level statements about your system, but now you want to go into a functional architecture. You have to somehow come up with what is it that your system is made of, what are your parts, the building blocks, call them components, and how do they interact. And this can be done by using this scripting language for high-level things. For example, if you interact with, let's say, the aircraft, then you get an error that says that the UI seems to not collaborate with aircraft. So, there is no expressed dependency in the model. So let's fix that. Let's add a dependency collaboration, and then you can say, I don't know, start flight is a stupid example now, but you can also create this capability from here. And now what this leads to is that now your UI has a dependency to the aircraft, and your aircraft has a capability, start flight. And so after coming up with a number of these scenarios, this will lead to a set of actors, components that have all the capabilities, all the collaborations, and all the data items needed to run a representative set of scenarios for your system. In other words, this helps you come up with a functional architecture with the, which components do you have, what capabilities do they have, which data do they own, and how do they communicate with others. So that was a quick overview over the requirement stuff. Stay tuned, this will be enhanced in the future. It's an interesting area.